Good day and welcome to the August Pacific Northwest Drought Early Warning System, Drought and Climate Change Outlook webinar. My name is Britt Parker and I'm with the National Integrated Drought Information System. This bi-monthly webinar series hosted by NIDIS and the USDA Northwest Climate Hub and Oregon Climate Change Research Institute is designed to provide partners and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar will be tailored to reflect recent, current, and forecasted conditions and climatic events, but will also include discussion of observed impacts and other relevant updates from across the region. Webinars and recordings and other supporting materials will be posted on drought.gov later this week. Note that after today's webinar, you'll have the opportunity to provide feedback that will help us improve this webinar series. So please take a moment and tell us what you think. So we have a little bit of a different lineup for this webinar. We're going to start with our traditional climate recap and current conditions with Joe Casola from NOAA's National Centers for Environmental Information, Western Region. We're then going to hear from the 3 states in the region about current conditions and impacts. So we'll hear from Nick Bond with the Office of the Washington State Climatologist at the University of Washington, from Larry O'Neill with the Oregon Climate Service at Oregon State University, and from David Hokema with the Idaho Water Resources Department. Then we'll hear a bit more from Joe on our seasonal conditions and climate outlook. And finally, we'll have a brief introduction to estimating drought recovery in the Climate Toolbox with Katherine Hedgevich from UC Merced. Before we begin, I just want to briefly highlight the partners that make this webinar series possible. The first is the Northwest Climate Hub, which develops and delivers science-based, region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. And you can visit their website. We'll put their link in the chat box. I would also like to highlight the Oregon Climate Change Research Institute, which is a network of dozens of researchers at Oregon's public universities that work closely with other public and private entities. OCRI is housed at Oregon State University and advances understanding of regional climate, impacts, and adaptation, and cultivates climate-informed communities. NIDIS was established in 2006 by public law with a mission to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS is building the foundation of a national drought early warning system through the development of regional DEWs, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize the impacts and early warning information differ across regions. Each DEWs has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their region. The Pacific Northwest DEWs was officially launched in February of 2016, and our strategic plan and information on current activities is available on drought.gov, and that link will be in the chat box also. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join CocoRoss, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, rain, hail, and snow, as well as condition reporting. Observations by CocoRoss observers of precipitation events or the lack thereof are important to capture and improve our understanding of weather. To become a volunteer or to learn more, visit cocoross.org or contact your state coordinator, and we will drop their names and emails in the chat box. We also wanted to highlight again the condition monitoring observer reports on drought, or CMOR drought impact reporting system. You can use the Seymour system to report drought-related conditions and impacts within the U.S. and its territories. This is a nationwide service provided by the National Drought Mitigation Center based at the University of Nebraska-Lincoln. It was developed in partnership with NIDIS and the U.S. Department of Agriculture. Your report will become part of a permanent record, appearing immediately on an interactive map like the one you see here, visible to the public, including authors of your state drought monitoring and U.S. drought monitor and the media. So we're definitely looking for more volunteers to support drought impacts which you're seeing or experiencing. And the record can be input on both desktop or mobile devices. And we're going to put into the chat box a fact sheet and website where you can learn more. So please consider submitting your drought impacts. Finally, I wanted to highlight 3 upcoming events across the region. The first is the 12th Northwest Climate Conference, which is going to be fully virtual this year and will be held October 2 through 4. You can submit your abstracts and self-organize sessions now, and we will put a website for more information in the chat box. NIDIS will be co-hosting a workshop with the Confederated Tribes of the Salish and Kootenai for building drought resilience in a changing climate with the tribes of the Upper Columbia and Missouri River Basin. And so if you have any interest, please go to this website that we will also drop in the chat box. Lots of resources in the chat box today to learn more. And finally, please save the date. The Oregon-Washington Water Year meeting will be held on November 1 and 2, virtual sessions both mornings of that Wednesday and Thursday. The goal is to share and gather information regarding climate change impacts of the 2023 water year. Registration is free, but you do need to register, and we will place that link in the chat box as well. And so with that, I'm going to turn over the presentation to Joe to start telling us a bit about current conditions across the region.
Oh, give me a second here, Britt.
Yep.
Just cursor for a sec. Are folks seeing that slide yet?
Yes, we see your slide.
Okay.
Yeah, presentation. Perfect.
Okay, great. Sorry for the delay there. All right, so the summary of recent conditions. We've seen the drought conditions grow more severe in essentially the same spatial pattern that we took a look at back at the June webinar. And a lot of the cause for that is things were warm in the summertime. And we'll take a look at the temperatures in May, June, July, and August. More locations were dry than wet, but there was kind of a mix. Even the Tropical Storm Hillary dumped a bit of moisture into parts of eastern Oregon and southern Idaho. But overall, more spots were probably a little drier than average. All to say, I mean, it's not a wet or dry period, not a wet period in the Northwest during these months, but just not enough moisture around to really offset a lot of drought. And then we'll talk a little bit more specifically about what happened in May. And I have slides that Aaron Wharton from NRCS and Jeff Marty contributed, and I really appreciate it, that kind of show what I'm colloquially calling the run on the Snowpack bank, and kind of how that's left us looking for stream flow, soil moisture, and reservoir storage. So first, the current drought monitor. So you can kind of see kind of a worsening of conditions in Western Washington and Western Oregon, as well as kind of through Central Oregon and into kind of the Northern Idaho and Northwestern Montana areas. And if you want to compare this to what we saw in the June webinar, the spatial pattern is really similar. We just see kind of the creeping up of kind of the D2s and the D1s and the D2s, and then the small area of D3 in kind of the northwestern corner of Montana. So how do we get here? So this is plots from Climate at a Glance of the ranks for temperature and precipitation for May, June, and July. And so the temperature is kind of running across the top, precipitation the bottom, and the color codes are related to the ranks. So those deep reds that you see in May, that's actually the warmest May in record for the climate divisions. And then the lighter colored reds are in either the top 10 percentiles or the top tercile, the top third. But you can see pretty steadily warm through a lot of the region. And then this mixed bag of precipitation is shown in the second row, more drier than average. But again, this is not a time of the year where we'd expect a lot of rainfall in the region. And in August, we're just switching to the climate toolbox, only because NOAA hasn't finalized their August numbers, but you can see again that this continuation of warmth across the region with for August in particular, the kind of coastal area is getting some of the largest anomalies. And here is that kind of, I think to the right, you can see the precipitation anomalies and some pretty significant dumps of rain in eastern Oregon and Idaho, and the middle of Idaho. And I think I suspect some of that was actually from the remnants of Hillary. So I want to get into this May story with kind of the run on the Snowpack bank. And we have to set ourselves up by looking at where we were on April 1st. And here was the snowpack situation. I think most of us would look at this and say, hey, that's not too bad, with the exception of the kind of Olympics, most of the Cascades and a lot of the kind of Idaho and Montana areas are, close to the longer term median, if not doing better. So we would think kind of starting, at the end of the accumulation season that we'd be in store for a decent kind of stream flow situation through the summer and into the early fall. And here's the beginning of the slides from Aaron. And you can see at the top left, that's the temperature in April. So things kind of stayed chilly. The snowpack didn't really come off much. And then in May, some really, really warm temperatures, especially in the northern part of the Columbia River Basin. And those dark red colors correspond to anomalies above 6 degrees Fahrenheit. To the right is a map showing the amount of SWE lost during the month of May. And those reds and oranges are kind of the second kind of largest amount of SWE lost, or the most, that's for the red. So you can see kind of up and down the Cascades, as well as in kind of the northern portions of Idaho and Montana, especially lots of those reds and oranges there from that this temperature really just caused the snow to melt off really rapidly. Another kind of look at kind of that snow loss story. On the left is the date of meltout, and the hot colors are where meltout happened earlier than the median, and the cold colors are where it happened later. And so you can see what's interesting is kind of I think the north and south split here, in the southern part of the southern half really of the Columbia River Basin. Oftentimes the snow melt was later than the median, probably owing to the fact that those areas got the most snow. They were kind of above median by a larger amount. But if in the northern half of the Columbia River Basin, you see early snow melt by as much as 2 weeks in those red colors. And Jeff Marty provided this picture right, kind of a snow hydrograph for this Washington state altogether. And you can see, things are looking pretty good kind of all throughout the month of April. You even had some continued accumulation, at least statewide, up until May 1st, and then a real precipitous drop off to where the SWE is essentially gone in early July. And how this translates into our observed and forecast stream flow. You can see that observed stream flow, in April was a little bit above normal, and into May quite high because we were melting off all that snowpack. And then we dip down below, and I should have noted this kind of orangish peach color, that's at 75% of normal. So that's that numerical threshold that Washington State often uses for thinking about should we declare a drought declaration. And so you can see we're solidly, kind of between the 50 and 75% numbers for June, July, and then the forecast for September, June, July, and August, and then the forecast for September. And then this is more kind of looking at that observed stream flow, and this is on the left is the hydrograph for the Pacific Northwest region. And again, you can see that big jump up in the stream flows in May with the really warm temperatures, and then just kind of crashing through the summer. So now we're into our kind of lowest 5, or maybe in kind of below 10 percentile on this particular plot. And then you can see on individual stream gauges, a real predominance of these reds and oranges, which are below the 25th percentile for the oranges and below the 10th percentile for the reds in Northwest streams. So as far as like where water is sitting, you have quite a mix of stories. So I have the reservoirs kind of shown at left in the teacup diagrams, and then soil moisture at right. And I want to call out Southeast Oregon, where the situation actually doesn't look too bad. That was one of the areas where the snowpack was relatively high, and not all of it probably came off in May, or it was if it did, it was able to at least be captured in these reservoirs. And this was kind of the poster child of the drought for the last few years, the kind of Southeast Oregon area. So a lot of these reservoirs have had dramatic improvement. Then in the kind of middle column here is the Yakima and the Deschutes, and you can see that especially as you start to move farther west in these systems, much less kind of runoff was able to be captured, and these reservoirs are quite low. And then at the far right, we have the soil moisture story, and it kind of corresponds with where the warm temperatures of the summer have been and where the stream flow has kind of left us. And so you see really low soil moisture kind of along the in between the coastal mountains and the coast, and then slightly better stream flows, soil moisture conditions farther inland. And I think that's all I have here, Britt, until we get to the outlook.
Great, thank you. So I'm going to take presentation back and turn it over to Nick. Let me try that again. Okay. There we go.
Very good. Nick Bond here. And yeah, so Washington State, 12 of our counties are officially in emergency status, which means water supplies are 75% or less than normal, and there is hardship. The remainder of the state is in a drought advisory status. Next slide. And here, just kind of repeating a little bit of what Joe just mentioned, but somewhat different perspective, of course, just for Washington State. And going back 2 years, I direct your attention to the first half of this duration hydrograph of the summer of 2022, in which we had a cool, wet spring. And the stream flows were really pretty healthy in the summer, but then the fall rains were started extremely late, and so there in late September and October we're down at 5 percentile sort of values. Compare that to towards the right in 2023, where, as Joe mentioned, high stream flows in May, and then the snowpack melted away, and so all summer we've had low stream flows. And I shudder to think if we have another late start to the fall rains, what those flows will be like in September or October. All right, next slide. And let's skip this one, just to say that actually from a storage point of view, though, in the Yakima system, on August 1, the storage was actually worse than it was in the snowpack drought year of 2015. So that's pretty bad. All right, next slide. And we're going to get into impacts here. This is a shot of some row crop that's not doing very well in Skagit County. There were some interruptions in irrigation supplies there that certainly are going to impact yields. I just checked the weekly crop bulletin, and it turns out in Washington State, the spring wheat, 37% of the crop is in very poor condition, and the remainder, most of it, is just fair. The pastures and rangeland, over half of the areas are in very poor to poor conditions. So there's obviously being some impacts on agriculture. Next slide. We're seeing some of the small water systems running out of water. And here's just an example. To be sure, small water districts, but in various parts of the state, including the northwest corner of the state, the normally pretty wet Olympic Peninsula, there are some places in which they're having to truck in water. All right, next slide. We're seeing impacts on our streams here. This is a temperature time series for the Nooksack River in northwest Washington state. And direct your attention to the green line in the kind of the upper part there, shows the temperatures from April 1 through last week. And that gold line is the normal temperatures. And you can see with those low stream flows, elevated stream temperatures, salmon don't like to be up there in the high 60s and 70s. And just recently it's cooled off a little bit, but certainly there are some impacts. And if we go to the next slide, we can see one. You're starting to see some mortality of sturgeon. This occurred in 2015 in the Columbia River. That's showing up again this year. Next slide. And there are some activities being carried out to do something about that. We're trying to create channels in streams for migrating fish, adult salmon returning, just like was done in 2015. There's some places in which you're using visqueen and hay bales to create some temporary channels. And so trying to do something about it. All right, next slide. And oh, yeah, fires. In some ways, we've kind of dodged a bullet. We've had plenty of fires and some smoke, and there in the northwest corner of the state, there's some pretty bad air quality in the past week, but we haven't had just a huge forest fire, at least yet. There's plenty of fire season left, and so a lot of us are kind of holding our breath there, pun intended. All right, last slide. Yeah, I just want to emphasize one of the points Joe made, and that is, what we're appreciating here is that the weather of spring really matters. It's not just all about the snowpack. And we're already seeing impacts in Washington State on agriculture and freshwater ecosystems, and some more are liable to emerge. And I think a really key thing that a lot of us are watching is just when will our favorable fall rains return. And with that, I appreciate your attention, and I think I'm going to be turning it over to Larry.
Great. And before we go to Larry, Erica, are there any questions for either Joe or Nick?
Yeah, there are a couple questions for Joe. One question that Ann Mullen posed: how does low soil moisture respond to September and October rainfall?
Good question. I mean, I am not a soil moisture expert, but I would imagine that if you can get that rainfall when it's still relatively, and it's not a super hot September and fall, that would improve the situation considerably. I'll show in the Outlook, unfortunately, That's not in the current outlooks right now, a particularly wet period. But if that were to happen, and I always take the monthly and seasonal outlooks with a big grain of salt. If that were to happen, that would help. I think that you would see some amelioration of the drought conditions.
If I could just add a little bit there, we saw in Washington State, because of the dry fall, going into winter, the soil moisture in our mountains was subpar, and then it got cold, and you know, they kind of iced over, and so it remained low soil moisture through winter, which is really unusual. And so it meant that that early snow melt was just moistening the soil rather than running off the hill.
Great. And there's one other question that I think either Nick or Joe could answer. Penny Longwell asked, where might there be information about the current condition of groundwater near Olympia, Washington?
Yeah, I can take that one. There's a kind of index well quite near Olympia, Washington. And if she were to email me, I could send her a link to that, or I'll put it in the chat while Larry's holding forth.
Great, thank you.
Okay, Larry, we'll turn it over to you.
Great. Good day, everyone. My name is Larry O'Neill, and I'm the state climatologist of Oregon and the director of the Oregon Climate Service. And I'm just going to give a quick briefing on the conditions in Oregon. They're a little bit more specific to how the water year has transpired so far. Next slide, please. So far, it's been a more eventful water year in terms of drought severity than we were hoping, given the good condition of the snowpack last winter. So far, we have 9 counties that have a governor-approved drought declaration at the state level, and we have 3 counties that are pending. Most of these counties are located in Central Oregon, which has been kind of the epicenter of our current multi-year drought cycle going back to 2020. So that includes everything from Deschutes and Crook County up Jefferson, Wasco County. And then a trend that we're starting to see is there are very low stream flows and some impacts from warm water, harmful algal blooms, and things like that that are tied more to drought in Western Oregon. And so we're starting to get more inquiries from counties about potentially having drought declarations. So there are 3 that are pending right now, and I wouldn't be surprised to see a few more coming. Next slide, please. So one of the reasons that drought conditions have deteriorated so much over the summer is that we had a really dry start, end to spring and start to the summer. And here's just a map of a county level precipitation ranking from May through July. And you see that most of Western Oregon was in their lowest 10th in terms of the 128-year data record. And then several counties, including in the Willamette Valley and along the coast, had their driest May through July on record. And one of the things that's really interesting about Oregon is that's really a key part of this water year is the northeast to southwest split in the state. So the southeast part of the state has been much wetter than normal, and they really took advantage of the atmospheric rivers that hit California during the wet season, and then they've also had quite a few thunderstorms and even the remnants of Hurricane Hillary that have gone through. And so when it rained there, it really poured. And so drought recovery in Southeast Oregon is either fully complete or it's at least partially recovered from the drought. However, the big story is the degradation of drought conditions in Western Oregon. And this has been really impactful, obviously, for wildfire season. So we're starting to see lots of the landscape's very receptive to any ignition. And so we have right now a lot of wildfires that have been started by the lightning storm last week, and then just in general, lots of small fires. So even though our fire season hasn't been the worst, it's still been very active, and it's probably not going to be as bad as it could be because of the quick response to the fire agencies to putting these fires out. Next slide, please. And then in terms of complete water year, you can definitely see this southeast to northwest split in the state again, where the southeast part is in one of their wetter years on record, and then the northwest part and the northern tier counties are in their bottom third in terms of driest. And so Oregon as a state so far, the water year 2023 is ranked as its 36th driest overall. Next slide, please. And compounding the lack of precipitation over the last few months has been some historically strong evaporation. And so this just shows a map for the last 3 months over the entire US. But if you look at Oregon, Oregon has some of the highest evaporative demand in the country right now. And these red colors indicate percentiles. So the darkest red color indicates that it's in the 98th percentile. So the evaporation from the landscape has been extremely strong and has really compounded the drought impacts, the impacts from too little precipitation over Western Oregon. And it's also, yeah, and there are a whole host of impacts from increased wildfire risk. The fuel moistures are very low right now. And then it's also contributing to very low stream flows that Joe showed earlier in Western Oregon, and contributing to very warm streams and low stream flow numbers. So next slide, please. And I just want to zoom in again on this soil moisture. So soil moisture is one of our most key drought indicators because it combines all the processes of all the meteorological processes into kind of a simple variable. So in Western Oregon, we see that we're having extremely dry soil moisture. So the darkest red is something that would be close to historically dry soil moistures. And so this is very shallow soil moisture, so it's about 2 inches. So it responds fairly quickly to either precipitation or heat wave events. And again, you can see this northeast to southwest or northwest to southeast split, where the southeast Oregon is actually historically wet in terms of this soil moisture product here. This particular soil moisture product is probably overdoing the surface soil moisture in southeast Oregon. It's probably not quite this wet, but it is definitely much better than it has been the last few years and definitely above normal. So next slide, please. So given this surface soil moisture, why is a lot of Central Oregon still in drought conditions? So that we still have D2 or severe drought hanging around. And the big reason is because of the deeper soil moisture. So it's the top 3 feet of soil just about. And this often takes a couple of years to really replenish. And so our drought cycle going back to 2000 really sucked out a lot of the moisture in this deep soil column. And this map just shows the dark reds are where we still have very dry soils in the top 3 meters, even though the surface soil is in a lot of these places are still has more moisture than normal. We're just waiting for it to kind of trickle down and replenish a lot of the deep groundwater sources. So next slide. And this is the last slide I want to end with. So it's just as our reservoir status graph that I make. And this just shows our major reservoirs and where we're at right now and how it compares to 1 month ago and 1 year ago. And essentially, the eastern part of the state, most of the eastern part of the state is doing great. We're either at average capacity for this time of year or well above average. So for instance, Warm Springs, Oahe, down in Malheur County, the southeastern part of the state are well above average right now and much better than we were doing last year. But the problem areas of the state are a little surprising given the snowpack. One of them is the Wickiup in Deschutes County, so right in the middle of Oregon and the eastern side of the Cascades. Wickiup is very low right now, so that's at the headwaters of the Deschutes River, which flows north into the Columbia. And this has caused a lot of problems with keeping stream flows and stream temperatures up in the Deschutes, and has led to curtailments of irrigation water and other associated impacts. And then very surprisingly, actually, is the Willamette Valley system of reservoirs. So in Western Oregon, so even though we had a good snowpack, a lot of the Willamette Valley reservoirs are rain dominated, so they get the bulk of their water from rain. And we've actually been below average for the water year in terms of rain. So we're kind of starting out in a dry point anyway. And a lot of these reservoirs are well below average right now and well below where they were last year. And some of this is actually due to a change in operations where the Army Corps of Engineers are operating the releases a little differently, trying to keep more water in stream into the Willamette River. But one impact that we've noticed the last few weeks are stream flow temperatures are well above average, about 4 to 8 degrees Fahrenheit above average in the main stem Willamette. And these reservoirs have drafted down to such a point that there's not enough cold water to keep that to keep the reservoirs or to keep the rivers at a cool enough temperature. And so we're starting to see a lot of harmful algal blooms up and down the Willamette, and because of the warm temperatures. And then we're also seeing adverse impacts on fish and everything else, consistent with what Nick showed up in Washington. So that's all I have. Thank you.
Great, and I'll turn it over to Erica in case there are any questions for Larry.
Yeah, Larry, there was one question from Michael Fagan. Which 3 counties are there pending drought declarations for?
In Lincoln, Douglas, and Gilliam counties. And yeah, that's what we have right now. And I've heard of a couple others in Western Oregon that are considering, their county commission are considering applying for it, but it's getting kind of late in the water year. And so, there's some counties that are, are just considering waiting and seeing how the early part of the fall plays out.
Great, thank you so much, Larry. I'll turn it over to David.
Okay, you can hear me, Brett?
Yes, we can hear you.
Okay. You can go to the next slide. I'm David Hokum, a hydrologist with the Idaho Department of Water Resources. And they put me last because we've got good news, at least in the southern side of the state. The northern side of the state sounds a lot like what Larry and Nick have been sharing for Washington and Western Oregon. This here is a 11-month standardized precipitation and evapotranspiration index. It's a really good drought index for the Western United States, where evaporation is a key part, not only precip, but the evaporation and its departure from normal. And so the blues represent wet and cool typically, and the yellows and reds represent drier and warmer than normal. So this gets us up through the end of July, but not into August. So I'll show those in a little bit, but you can see as a whole for the water year through the end of July, the Western United States has been pretty wet, especially in the Southwest, and Southern Idaho has really benefited from that. And so if you go on to the next slide, which shows stream flows to date. This is from the NRCS interactive map, and then down in the corner I've got the Northwest River Forecast Center water supply forecasts, which pretty much are observed at this point since the water year is almost over. And although it's difficult to see the percentiles here, these reds really represent percentiles that would be considered as a severe drought by the United States Drought Monitor. They're between the 5th and the 10th percentile, or 6th and 10th percentile. But then as we head south, you get these blue colors, and as you go down into the Bear River Basin and southern Idaho, which is actually outside of the Northwest Dews, but they had a spectacular snowpack and really good stream flow. And then the mountains here in central Idaho also have pretty high percentiles in the 77th, 71st percentile. And you can see that transition from blues to reds, really the story of the water year this year. If we can go to the next slide. This slide is precipitation through August, and you can see the kind of Hurricane Hillary's impact coming up into California, Nevada, and then up into southern Idaho, especially hitting the central mountains like Joe showed in his update. And so go on to the next slide. And the stream flow response has been spectacular. In 2021, we had our driest spring on record. And so we had especially impacted the rivers in the central mountains of Idaho. And then in 2022, we had a really cool and wet spring, especially in the central mountains. And we were able to recover from drought with less than normal snowpack in 2022. So you'll notice not only did we recover from drought, we had really good runoff with the stream flows being above the average shown by the brown triangles. But then when the remnants of that Hurricane Hilary hit, the stream flow jumped from 200 CFS on the Big Lost River up to around, I think that indicates about 13 to 14 100 CFS. So a huge jump. That's record-setting stream flow in that basin. And if you look at the Big Wood River, this is coming out of Sun Valley in the Central Mountains. It too had a very similar jump. You go down to the Boise River, it jumped from an average, a little bit above average stream flow of 300 CFS up into around 1,000 coming down on the South Fork of the Boise River. And then the Salmon River, which is a little further north, it was running below normal stream flow. But then again, that jump really spiked stream flow. So this is really good news. On the Big Lost River, this has given them about an extra week of irrigation this season. And so what we're seeing again is not only did the spring, but this fall precip has just done wonders for southern Idaho and has put us in a really good shape for going into the coming winter. So hopefully we get the good fall rains that everybody's hoping for, and that will really set southern Idaho in good shape. But again, it's this contrast between really dry conditions up north and drought recovery across all of southern Idaho this season. And with that, I have one more slide. This shows reservoir condition, the reservoir systems on the Boise River, which covers a lot of western Idaho's irrigation supply, and then the Snake River. The red is average conditions. And so the previous year on the Boise River, you can see the green, we were below average. And despite having a pretty dismal snowpack, we had a very cool, wet spring, which allowed us to fill above average. And we came off above average. And this year, we started off above average, and we're going to end up even higher than last year. So we're building up some good carryover in the system. You can't see it real well in this graph, but there's a bit of a pull upward right at the end, and that's the remnants of Hurricane Hilary. And then on the Snake River system, average, we usually start the season with 1.5 million acre feet. Last year was pretty dismal, but that cool spring helped extend the irrigation season of what could have been a disaster to the end of the year. But then this year, with a cool wet spring that impacted the upper Snake, we were able to get just above average. We didn't quite fill the reservoir system, but now we're coming down to a more average condition. And with that, that kind of wraps up the presentation from Idaho. So good conditions in the south and pretty rough up north, where severe drought conditions are really impacting the stream flow.
Great, thank you, David. Before we turn it back over to Joe and then to Katherine, do we have any questions for David, Erica?
Yeah, there was a question about why is evaporation an important factor for water indices in Western United States?
Especially when you get away from the coasts, we have very little precipitation in the summertime. And so if you have a cool summer, then the crops, which is our major water users, the farmers, the irrigators, If you have low evaporative demand, then you're diverting less water out of the rivers, and it allows more to remain in storage as carryover for the following season. But if you have really high evaporative demand, and of course we don't have the precipitation to meet that, then you've got to draft the reservoir system to meet that high evaporative demand. So that's kind of why we really care about evaporation in the summer, because we don't have precip, and it's that departure in the summer time that is critical to how different water years turn out.
Great, thank you.
Joe, we'll turn it over to you for the outlook.
Great. Is my slide visible?
Sorry, it is.
Good. Okay. I'll go quick here. Looking at just the next couple weeks, kind of the 8 to 14 day forecast, it looks like kind of an elevated chance of cool and wet. So might be a little break from some of the warm temperatures for a lot of the summer. The monthly seasonal outlook, there doesn't look to be kind of any drought busting precipitation on the horizon, and fire potential remains high in the Northwest. I'll talk a little bit about El Nino at the end. El Nino conditions are present, and there's a very confident forecast for it to continue through the winter. However, I think we still need to be in kind of the wait and see mode in terms of what the impacts would be in the Pacific Northwest or really any other region in the U.S. So here are the 8 to 14 day outlooks. On the left is temperature, on the right is precipitation, and the colors correspond to the odds, to the chances for a particular anomaly. So we have slightly elevated chances for cool temperatures and elevated chances for wetter conditions. So maybe a little bit of a break from some of the heat of the summer. And I think you guys are already into some of that right now. As far as for the monthly outlook for September, not a heck of a lot of information in the CPC forecast. Most of the region kind of equal chances for warmer or cooler than average, with the exception of the far eastern part of the Northwest, and then really not much kind of tilting of the odds for the precip for September. For the longer term outlook, September, October, November, you see kind of the elevated chances of warmer temperatures with the elevated chances for dry. And the temperature picture, I feel like, is this way more often than not. Just it's capturing a lot of just the trend that, you know, any given season it has a better chance of being warmer than the last 30 years. For the precip one, I looked in the forecast discussion a little bit. I didn't see much to kind of provide any explanation, and maybe others on the call might have that as far as why there might be tilting towards drier than average. But I think the consequence of that is continued drought conditions. And so this is the drought outlook through the end of November. And, you know, the kind of Washington and Oregon area continue to be included. You know, the exceptions in the Northwest are southeastern Oregon and the southern part of Idaho, which, as we just saw in the last two talks, are hydrologically looking pretty good. But for the rest of the Northwest, things are expected to persist, and in areas that have yet to have cross into to perhaps the drought monitor categories, they may join the club. With those drought conditions, we also expect to see continued fire potential. And I decided to show the North American picture and not just stop at the border, because so much of the activity in British Columbia has impacted the Northwest and other parts of the continental US. And so unfortunately, the continued drought conditions are kind of supporting continued fire potential that even continues into October. And I think that's very concerning to see this kind of the western coastal area, Washington and Oregon, being noted, as well as California, as areas of high risk. You know, I think that, or high potential, pardon me. That's probably rare once we get into the fall. So something to keep our eye on of whether you know, these seasonal outlooks pan out, and whether there is more fire activity late in the season. So getting to El Nino, on the left, this is the sea surface temperature anomaly for the approximately 30 days ending in last week. And you can see that kind of telltale warm anomalies, that tongue of warm water extending off of the South American West Coast. And this may be one of the most confident El Nino forecasts I've seen in quite a while, but really for almost all the seasons of the winter, we really expect these El Nino conditions to stay. If we look at the plume of kind of just how strong the El Nino might be, there is kind of strong, I forgot to make this text bigger, sorry, to make folks squint, but a chance for a strong El Nino, and CPC was saying roughly 2 and 3 chance for that, and they consider strong to be above 1.5 degrees. There are a few models here that are still pushing for the above 2 degrees centigrade in the tropics, so we'll have to again keep an eye and see just how this event evolves. As far as impacts go, this is kind of the canonical picture of what El Nino does. If we've learned anything from the last few ENSO events, is that the canonical picture does not always materialize. But for El Nino, this is usually the story. We have a kind of extended Pacific jet that tends to have less waviness to it, kind of gets trapped in a way or kind of pinned into the farther south than it might normally meander. And that leaves the Northwest and a lot of the northern tier of the United States warmer than average and brings often cooler and wetter conditions to the southern part of the country. However, and this is kind of a chaotic one, I just for kind of kicks, call it choose your own adventure. On the left is a panel of 20 different ENSO events, and they're categorized by strong, moderate, and weak. They're probably too hard to pull out, but I just wanted to zoom in on the 4 strong ones and 4 of the moderate ones to show that you can get precipitation amounts of all sorts during these ENSO events. So just to kind of break this potential connection, yes, we can have a strong ENSO event, but that doesn't necessarily mean we get strong or canonical impacts in the Northwest or really almost any region in the country. We still have to see how the teleconnection's set up and what the jet stream really does do. And I think in at least the end of August, I'm not willing to make any bets one way or the other. And with that, I'll close and take any questions and turn things over to Katherine.
Great, thank you, Joe. And in the interest of time, we'll go to Katherine and then take some questions at the end. So Katherine, I am giving you presenter control.
Did you give me presenter control? Oh, I'm sorry.
Yeah, I can try to do it again here. Let's see. I'm going to try again. Give me 1 second. I had to take it back. Okay, should be coming to you. And if all else fails, you can send me your slide and we can go to a question while I bring it up. So either one.
Let me, I'm going to send my slides.
Okay. Erica, do we have any questions?
Yeah, we do. And this one maybe is one that Larry might want to take. Steve Lawton says he's trying to make decisions over a 50, 60-year period of time on what tree species to plant for reforestation in the hills adjacent to Western Oregon. And he asks whether he should lean towards species that are more resilient to a long-term trend toward warmer and drier climates.
Yeah, so I'm not an ecologist, so I can't answer the part about exactly which tree species you should plant, but the trends in the projections do indicate that the summers will be warmer and drier, so there'll be prolonged periods of prolonged heat waves and less precipitation during summer. And then the winter, the temperatures, of course, will be warmer, and there'll be less snow, and but there possibly could be a little bit more precipitation during the winter. And then over the annual cycle, they'll be about the same as there is now That's what the projections are showing. So yeah, so it'd definitely be a consideration for making sure that whatever you do plant is resilient to basically warmer and drier summers that have more evaporation and can withstand those kind of drier conditions.
Great, thank you, Larry.
If we're, we have one more question, if we're still waiting.
Yes.
So there's a question, is there any, and maybe Joe wants to take this or anyone who can chime in, is there any information available on forecasts for ocean temperatures, particularly below surface level?
Yeah, that's a great question. I know that some of the ocean temperatures, and Larry, you may want to jump in on this too, like in the North Pacific have been really warm, and there's been some pretty significant marine heat wave activity. And as far as I know, there is a CPC forecast for the North Pacific, and that was looking pretty warm too. So I anticipate that given the kind of longer timescales with the ocean cooling down, that those things will stick around. But I certainly defer to an oceanographer in all things sea surface temperature and subsurface.
Yeah, I guess the time, I just have a question about the time scale of the forecast. If it's just on a seasonal time scale, I don't know. Yeah, the seasonal time scale, the subsurface down to about 100 meters depth or about 300 feet, typically follows pretty closely the surface temperature, so sea surface temperature. So forecast for sea surface temperature, you can kind of use that as a proxy for the little bit deeper, the ocean mix layer essentially. As far as like climate projections go, is that the projections show a pretty grim story that the surface or the ocean will warm at all depths, and it'll be surface intensified down to about 200 meters, which is about 600 feet. So there'll be basically more heat stored subsurface, and then yeah.
Great, thank you. Katherine, I have not seen a slide come through yet.
Oh, I sent it. I mean, yeah, I think given time, it's okay if I don't go this time.
Okay.
It's fine with me. I can do it next time.
Okay. That's fine. Thank you for your flexibility there, and apologies to everyone. We definitely wanted to have an update on all the conditions across the region and impacts. So we will go ahead. Eric, I'll just check once more to make sure there's no other questions.
Nope, I think we have covered all of the questions. Thank you, everyone.
Yeah, thank you guys so much. And we will make sure to give Katherine a bit of time on our October webinar if she's available, or certainly one of the upcoming webinars here in the next couple months. Thank you everybody for your participation today, and we will see you. Our next webinar will be October 23rd at 11 a.m. Pacific. Thank you, everybody.